began not with an explosion, not with a discovery, but with a contradiction. One so severe, it threatened to break the foundations of modern cosmology. The contradiction came from the work of a single man, Adam Riess, Nobel Prize in Physics, explorer of the expanding universe, the scientist who uncovered dark energy itself. But years after his first discovery, Riess found something even more unsettling, something the universe should not be doing. The universe was expanding at two different speeds, a cosmic impossibility. His discovery would ignite a debate that still rages today. Did the laws of physics change? Adam Riess was not searching for controversy. He was doing what he had always done, measuring the universe with precision no one else could reach. His specialty was the Hubble constant, the number that tells us how fast the universe expands. For decades, physicists believed the value was fixed, stable, universal, absolute. But Riess's measurements told a different story, a faster story. According to him, the modern universe was expanding too fast, much faster than the early universe allowed. Something wasn't adding up, or perhaps something had changed. When Riess compared his measurements with those from the early universe, the numbers refused to match. One universe, two expansion rates. Impossible. Physicists named the problem the Hubble tension, a polite phrase for a terrifying idea. The universe wasn't playing by its old rules. Physicists named the problem the Hubble tension, a polite phrase for a terrifying idea. The universe wasn't playing by its old rules. For Riess, this wasn't a data error, not an instrument flaw, not an observational glitch. It was a message, hidden in the stars themselves. Something in the universe had shifted, subtly, quietly, but undeniably. At first, scientists dismissed the anomaly, calibration issues, statistical noise, ordinary error, but as Riess improved his measurements, the gap widened. The universe was disagreeing with itself. If the early universe predicted one value, and the modern universe showed another, then the universe had two histories, two realities, or perhaps the same reality before and after a silent transformation. The question that haunted Adam Riess was simple. If the universe is the same, why is it behaving differently? His measurements showed that galaxies nearby were accelerating away faster than expected. The numbers didn't disagree by a little, they contradicted each other completely. Riess's data implied that something had changed in the cosmos. Long after the Big Bang, a shift, a transition, a reconfiguration of the underlying physics, and it happened relatively recently. Cosmologically speaking, when Riess and his colleagues first discovered dark energy, it was seen as a constant force, a smooth, steady pressure pushing galaxies apart. But the Hubble tension hinted that dark energy might not be constant at all. Some models suggested it could evolve, strengthen, or weaken, even flip behavior entirely. This possibility terrified cosmologists. If dark energy changed its nature, then the universe we live in is not the universe we were born into. A universe that suddenly accelerates faster might not be stable. It raises a haunting question. Can a universe outgrow its own laws? If the universe changed, then the first evidence would appear in the constants. The numbers that define the structure of everything. Scientists began checking them. The speed of light, the strength of gravity, the electron charge, the fine structure constant. The results were subtle, but unsettling. Nothing had changed dramatically, but certain measurements began drifting toward values that made sense in Riess's new cosmology, a cosmology where acceleration increases with time. If true, this suggested something profound. The universe may have undergone a phase transition, like water turning to steam, like metal becoming magnetic, a transformation of the cosmic medium, a door to a terrifying realization. The universe may no longer obey the same rules it obeyed 1 billion years ago. After the Hubble tension erupted, the scientific world split in two. One side argued that Riess's measurements were simply too precise, so precise that they revealed flaws in existing theories. The other side believed something more dramatic. The universe had evolved, not gradually, not smoothly, but through a shift, a sudden change in the behavior of dark energy. Something that once seemed constant may have turned dynamic, a force that evolved. If this is true, then the universe we see today obeys rules that did not exist billions of years ago. We are the first species to witness a living, changing cosmos. To many physicists, Riess's findings were not a crisis. They were a doorway into new physics, into a deeper understanding of the universe. If the acceleration of the universe is increasing, then something must be driving it. Some theories propose early dark energy, a burst of repulsive force in the young universe that changed over time. Others suggest the existence of previously unknown particles, dark radiation that influences cosmic expansion. And then there are more radical ideas, a shift in the fabric of space-time, a transformation in fundamental constants, a cosmic phase transition. These theories do not claim that reality broke, only that reality evolved. The same universe. New rules. We live in a time that no previous civilization, no star, no planet, no galaxy has ever experienced. A universe that is rewriting its own behavior. While we watch for humanity, this brings both fear and opportunity. The laws are shifting, then new possibilities may emerge. New technologies, new physics, new frontiers. But it also raises deep existential questions. Can a species evolve fast enough to understand a changing universe? Or does the universe evolve faster than the minds within it? Adam Riess never said, "This isn't our universe anymore," but his discoveries forced others to say it for him. He showed that the early universe and the present universe operate under measurably different conditions. He revealed contradictions that old physics cannot explain. He opened the door to a universe that might be evolving faster than the theories that describe it. The universe has not ended. It has not broken. It has changed. And now, humanity must change with it. We are witnesses to a cosmic evolution, the first in recorded history. The Hubble tension is not a problem. It is a message. A message that the universe is deeper, stranger, and more alive than we ever imagined. And its evolution has only just begun. Thank you for watching. Stay curious. The universe is listening. As the debate around Adam Riess's discovery grew, a new question emerged, one far stranger than the Hubble tension itself. Does the universe remember its past versions? In physics, memory is not a metaphor. Some systems retain traces of their previous states even after they transform. Cosmologists began asking whether the universe might work the same way. Perhaps the early universe left imprints that no longer belong to modern physics. Cosmic bruises. Some researchers called them strange alignments of galaxies, unexpected flows of galactic clusters, cold spots in the cosmic background radiation, patterns that do not match the laws we observe today. These anomalies may be fossils, relics from a universe that operated under different rules. If so, Riess didn't just detect a tension, he may have detected a transition. The universe is evolving. One question becomes unavoidable. Are we the first civilization to witness such a shift? Astrobiologists suggest that advanced civilizations may have vanished not because of war or disaster, but because the rules of their universe changed faster than they could adapt. Their physics shifted, their constants drifted, their technology, biology, and understanding no longer matched the new reality. If Riess is correct, then humanity is standing at the same threshold. A universe that may be shifting under our feet. A universe that demands intelligence not just to observe, but to adapt. Whether we survive this cosmic evolution depends on one thing: whether we are willing to see what the universe is trying to show us. We stand at a moment no civilization has faced before. The universe is shifting, slowly, quietly, but undeniably. Adam Riess revealed the first sign. Now it's up to us to decide whether we look away or look deeper. If you believe knowledge matters, if you believe curiosity shapes the future, if you want to understand the universe before it evolves again, then join us. Subscribe to the channel, because this is only the beginning. The universe has more to say, and together, we will listen.